that without the tiles, so let's show it with the tiles. So it's simply an area map, which means that I take the side length of one thing and multiply it by the other one. So what fits perfectly in here is actually going to be an x squared tile. And that makes sense because when I multiply an x by an x, I should get x squared. I should line them up a little bit straighter than I am now so that it fits right directly underneath. So x times x is going to be an x squared, and then the last thing that you have to take into account is whether it's going to be positive or negative. So for this, you're just going to use your basic multiplying rules. A negative times a negative is positive, a negative times a positive is negative, and a positive times a positive is positive. So here, for my first, I am multiplying negative times a positive, which means my answer is going to be negative, so I'm going to leave it unshaded. For my second one, I'm multiplying a positive by a positive by a negative again, so that one's also going to be negative. And then for my last one, I'm multiplying a positive by a negative, so it's also going to be negative. So now what I have inside is my answer. When I multiply negative 1x times 3x, my answer is negative 3x squareds. I have an x squared here, a negative x squared here, and a negative x squared here. So I have 3x squareds. All right, let's look at another example. All right, let's try this one here. Oh, wait. This is a trick question. You can't multiply anything that has x squareds with algebra tiles. So this one you cannot do. Only can do x's and 1's. Alright, let's try this example here. We have x squared times 2x squared. Well, what did I just tell you? I just told you that we can only do x's and 1's. And I have an x squared, so no, I cannot do this. And the reason is because it would have to go into the third dimension. Algebra tiles only show 2 dimensions. So no, because x squared times x is third dimension. Which would mean we would need a whole bunch of cubes, and that would really complicate things. I do want to try one more example with you. I want you to multiply 3x times 5x. So what does that look like? So the first thing we need to do is create a chart. I then go and put my first monomial on the left hand side. So I'm going to draw 3 x's. 1, 2, 3. And the key before was that these ones are going to be negative and I need positive, which means I need to shade them in. Okay, so 3x, that's going to go on one of the sides. On the other side, I'm going to put 5x. 1, 2, 3, 4, 5, and I'm going to shade them in once again because they are positive. Alright, so now I just simply do an area. So if I look at this space right here where I put the dot, I am multiplying x times x. So what fits in there? Well, x squared does. And then I have to decide, is it going to be positive or negative? It is going to be positive because I have x, positive x times positive x. So I need to shade that in as well. Right, what about this next space here? It's an x times an x again, and it's going to be positive. So I'm sure you're starting to see a pattern. I'm always multiplying a positive x times a positive x. So x squareds fit in there just perfectly. You'll have to excuse me shading. All right. Let's see. I've gone ahead and shaded the rest of the x squared boxes, so now if I count in total, I have 15x squared, so that means that my answer is 15x squared. So think about it as a... Go ahead and complete the skill check to see if you're on the right track for success. Here's the answers. First one is D, second one is false. The correct answer should be 36a to the 6th, b to the 6th. Alright, so for part B, we're going to be multiplying polynomials. That means we're no longer going to be multiplying just simple monomials. We have to use distributive property. This is something that you're going to be using all the way until grade 12. So distributive property, as shown in this example with the letters, means that if something is outside the brackets, it needs to be multiplied by everything inside the bracket. So we need to take A and multiply it by B, but then also A and multiply it by C. So the steps for multiplying are multiply the monomial by the first term in the binomial, then repeat the process until the monomial has been multiplied by all terms in the polynomial, and reduce if possible. So let's give it a try. So to illustrate this, I will usually draw in arrows over top. So I need to take the 2 and multiply it by the x. So 2 times x is 2x. And then I need to take the 2 and multiply it by the 4. 2 times 4 is 8. And keep in mind that's a positive 8, so that means that the sign here is going to be plus 8. If we were multiplying by a negative, it would be subtract 8. So 2 times x plus 4 is actually 2 plus 8 when we use distributive property, when we multiply. Alright, let's try the next one. Negative 3 times in brackets x plus 4. So the negative 3 needs to be multiplied by the x, and then it needs to be multiplied by the 5. So negative 3 times x is just negative 3x, and negative 3 times positive 5 is going to be negative 15. So that negative is just a subtraction sign minus 15. So negative 3x minus 15. Next example, negative 6x, negative 6 times in brackets x minus 2. So first, negative 6 times x is just negative 6x. And then what about negative 6 times negative 2? So remember this, the sign always needs to stay with the term that follows it. So we're actually taking negative 6 times negative 2. That's positive 12. So it means it becomes plus 12. So that is how you multiply a monomial by a simple binomial. We'll get into more complicated ones here. Alright, already getting a little more complicated. We have to take the negative 10 and multiply by 2x. So now we have a coefficient that we have to worry about. We have negative 10 times 2x. So you can take this as an extra step and write that out. Negative 10 times 2x. And then you need to take the negative 10 and multiply it by positive 10. So negative 10 times positive 5y. So that's how you write it out in an extra step. So you now have negative 10 times 2x, which is negative 20x, and negative 10 times 5y, which is negative 50y. few more examples for you. They're progressively getting harder. So now we're taking a monomial and multiplying it by a binomial, but our monomial at the beginning isn't a constant, it has a variable. So we still do the same thing. We take the 5x and multiply it by the 3x. 5x times 3x. But then we have to take the 5x and multiply it by the 2. So it's going to be, and here's where it gets a little bit tricky with the positive signs. So what you need to recognize is that the 5x at the beginning is a positive 5x. So 5x plus 5x times positive 2, or just 2. Right? So now we have 5x times 3x, which is 15x squared. We add those coefficients, plus 10x. So we're multiplying the coefficients and keeping the base the same. Alright, let's keep going. We have 3x times a trinomial. So now you have to keep multiplying it by everything inside this trinomial. So 3x times 4x squared. 3x times negative 7, and 3x, and I'm going to run out of room here, times 9. Can't end my bracket. Alright, so 3x times 4x squared, multiply the coefficients is 12, and add the bases on the exponents, add the exponents, so it's going to be x to the power of 3. Positive 3x times negative 7, and I forgot my x in there, is going to be, you multiply your coefficients. 3 times negative 7 is negative 21 x squared. And then lastly, 3x times 9, which is going to be plus 27x. Right, go ahead and try the last two on your own. I will write down the answers and you can check them when you're finished. Here are the answers for the next two questions. Please check your work. Make sure nothing went wrong, or maybe I went wrong. 6, 12, oh, I did go wrong. Let's see here. We have, just should be 18. Right, moving on to a little bit more challenging questions. We now have the same rectangles that we had before, but the area is not represented by simple monomials. So area still equals length times width. So for this case, it's going to be my length times my width. I need to use distributive property. The 5x needs to be multiplied by the 3x squared, and it needs to be multiplied by the plus 7. So the simplified version is going to be 15x cubed plus 35x. Go ahead and try the next one on your own. Here is the answer for our next example, 16x to the 5th, y to the 4th. So remember, you need to take the 8x cubed y and multiply it by everything inside the brackets. I'd like you to go ahead and try to complete the rest of the lesson on your own. They are a little bit more challenging, but we will go through these when I am back. I want to emphasize one last time how important the concept of distributive property is. You'll be using it all the way until grade 12. So whatever is in front needs to be in front of brackets needs to be multiplied by everything inside the brackets.